Are you buying electronics this holiday season? Then you'll want to hear from our guest today. She tests products in extreme conditions, and she has some tips for holiday shoppers, what to look for and what to avoid. Plus, a technique used for thousands of years in woodworking leads to a new discovery. That's ahead on breakthroughs. And we answer a listener question in Ask Us Anything on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast presented by Southwest Research Institute. Hello and welcome to Technology Today. I am Lisa Benya. A new breakthrough story and Ask Us Anything just ahead. But first, our guest today is SWRI engineer and product assurance laboratory manager Jenny Farron. She and her team test electronics and other products for safety, endurance, and reliability. She's here to talk about what these products go through before you buy them, and they go through quite a bit. And she has some tips for shoppers. Thanks for being here, Jenny.
Thank you for having me.
So you conduct product assurance on electronics and other consumer products. So what type of products do you test?
Well, we test everything from cell phones and laptops to the batteries that power them, batteries that may go into the toys that you buy for your children, tools and equipment that you might use in your workshop.
So really a range of consumer goods.
Wide range.
So what are you looking for during the testing process?
Well, equipment can actually be exposed to extreme temperatures and conditions while they're being stored in a warehouse, while they're being shipped to the buyer, and then while they're being used. And so what we're looking for is to make sure that that equipment can survive those conditions and perform properly once they're being used in your garage or in your home.
So when the product ultimately arrives to the consumer, the manufacturer wants it to be in good working order. So what type of tests are you conducting to ensure that for the manufacturers?
Absolutely. So a manufacturer generally provides a warranty for a product. And so they want to make sure that that product is going to last and operate throughout that warranty period so that they don't have to replace or repair it. So those conditions can be high temperature, low temperature, even a temperature shock if it's being shipped in a conditioned truck and then it gets pulled out into the middle of winter in Minnesota. So those temperature extremes can actually cause materials to crack or break. High altitude might cause a problem, or vibration and shock. If it's being shipped in a truck and the truck hits a pothole, or if it's being shipped in a plane, that continuous vibration during the transport can cause issues too. So part of what we do is to make sure that that equipment will survive the trip to the buyer. Once the buyer receives it, we want to make sure that that equipment will operate properly in those extreme temperatures. If you have a piece of equipment in your home office that's air conditioned, it has different exposure conditions than something that's going to be stored or operated in your garage in the middle of summer. Similar like a soda machine, if you have one in an office building, it doesn't have to work as hard to chill the soda as one that's sitting outside of the grocery store in the middle of summer. And so our job is to make sure that that equipment is ruggedly tested to extreme conditions to make sure that it can withstand those environments.
So these are a lot of different scenarios and possibilities that these products could end up in, scenarios these products could end up in. So how do you reproduce these scenarios?
Okay. Part of our job is to simulate those environments in a laboratory setting. So those conditions are simulated through thermal chambers, through shaker tables, altitude chambers, salt fog chambers, any way that we can bring that outside environment to a laboratory setting. That makes it a very controllable environment and therefore very repeatable so that we can ensure we're testing product A the same way that we're testing product B. That consistency is critical for a laboratory like ours.
So that caught my attention, a salt fog chamber.
Sure.
What is that?
Okay. So if you have a product that's going to be mounted underneath a vehicle in states that are commonly iced or snowed in the winter and they have to salt the roads, or you have a piece of equipment that's going to be used in your boat in a saltwater environment. That equipment is generally subject to corrosive environments and can actually affect how it operates or how long it survives. So we often expose anything from coated materials to batteries to radios to this salt fog environment where it's literally in a 100% humid environment of salt fog. And that really tests the corrosive resistance of those products to make sure that either it's not going to rust or that the salt won't build up and actually keep something from operating.
So best case scenario, I imagine, is you get these products and they are performing well, but what if your testing uncovers some weaknesses in products? How do you go from there?
Absolutely. So part of what we do is called stress screening. And so we're trying to actually discover how the products might fail. It's called the failure mode. Once we identify that failure mode, then we can actually test them to extremes in that particular environment and replicate how long they would survive or what the potential life of that product is. Once you identify that failure mode, then the manufacturer can actually make design changes and improvements to make that particular failure mode less likely to happen. And so it can actually extend the life. It can make a product more reliable. It can even make it safer.
So it's not unusual for you to have to send a product back to the manufacturer and say, okay, you got to go back to the drawing board for this particular issue.
Absolutely. Manufacturers send us products oftentimes for that very purpose. Please help me identify where this product can fail so that I can make the appropriate design changes. They can make design improvements that might not give them any additional life or reliability. They want to focus their attention on those aspects that are going to improve their product.
So here at SWRI, I know we test a wide range of products, as we mentioned, that come from manufacturers that are recognizable, that we would find on store shelves. However, we can't really name names, right?
Right. Most of our testing is considered company proprietary. So our consumers, because we are doing development testing, some of our products that we're testing have not been released yet. So their performance and even the design aspects are very valuable information. So we're very careful about protecting that information on behalf of our customers. We do not talk about the testing, we don't talk about the results, and we won't even confirm that we even performed the testing. The other part of what we do is government and military testing, and that information is public information. But for the commercial testing that we do, that information is not shared.
How many years have you been testing products now?
I've been testing at SWRI for nearly 20 years.
So 20 years of testing under your belt, and you've learned a thing or two about good quality versus not so good. So, of course, this is the busy holiday shopping season. Everyone's out at the stores or online looking for the perfect gifts for their loved ones. What are some tips? What can you help us with this shopping season? What should we look for, and what should we avoid?
Well, when you're buying Christmas gifts, it's very tempting to go for the less expensive option, but oftentimes you'll have equipment or products that have not been tested or not been evaluated to the same level as the more familiar brands. So especially for items with batteries or other consumer electronics, manufacturers who have done their homework often have that equipment listed. And so you'll see an actual mark on the product somewhere made by a certification body such as SWRI or UL or ETL. That mark indicates that that product has been tested and certified to be safe, that it won't interfere with other equipment, and that it has been evaluated by that certification body. Other products that have not gone through that might be cheaper, but they're not necessarily safe and reliable.
So how would we find this information?
You can find that information online. Those manufacturers are very proud of the fact that they've gone through that testing and have that certification. So they'll publish it in the documentation online. They'll also publish it typically in the ordering information. They want you to know that they've done that homework and that they've made that product robust.
We'll find this on the box probably as well.
You can find it on the box. You can find it typically online. A lot of manufacturers, because a lot of people order online, they'll publish the manual or they'll publish the information online. So you'll see, if you look for the mark, if it's been FCC tested, that means it hasn't been, or it's been tested to make sure that it won't interfere with other electronics. If it's been safety tested, safety certified, then it will have that certification mark from a certification body.
Okay, what are those certification body marks again? What will we see?
You'll see typically the company logo. Every company has their own mark. SWRI has its own mark that it uses typically for building products. Consumer electronics typically have a mark by UL or ETL or other certification bodies like that.
Okay, well, that's great information. And if you go the other route and you maybe save a few bucks and you don't see these, I mean, what are you risking if these products are not certified?
For battery-powered electronics, you're actually risking potential fires or other hazards. You're also risking a shorter life. Equipment that has gone through that kind of testing is typically more robust, and the warranty periods are actually longer. So another good way to look for electronics that you're considering purchasing is to look at the warranty period. Consumer or manufacturers who offer short warranty periods don't have much faith in their products. I don't know how many times I've bought things that stop working soon after the warranty period expires. So look for the warranty period. If they offer a longer warranty period, that means that they are confident that their product will survive and last that long.
Good to know, because you hear these things, but you don't. I personally hadn't paid much attention to it, but I will now. I've seen those marks and I've seen those letters, but never really knew what it meant. So that's pretty cool. So here at SWRI, we actually test much more than consumer products and what we find on store shelves. What else does your team test?
My team tests some consumer products, but we often test the infrastructure that makes those products work, makes those products interact. For instance, we've tested instruments that are mounted on satellites that help with communications. We've tested telecommunications equipment so that in the event of an earthquake, consumers can still pick up the phone and still get to emergency services and let them know they need help. We've tested large batteries for electric vehicles and for large forklifts. We've also tested guardrails and cable barriers and other roadside safety devices that are designed to keep you safe in the event of an accident. Even light poles and signs that are designed to break away if you run into them on the side of the road. We also do test ruggedized laptops and phones and tablets, oftentimes from military customers, because they want that equipment to survive long after a consumer would have expected it to stop working.
So I feel like this is just a lot of stuff we take for granted and just expect to work. But the reason it does is because, a lot of times your team is there making sure of it. So that's got to be a great feeling.
Absolutely. One of the things that we appreciate too is that manufacturers who come in for testing, they'll learn from the testing. They'll learn design changes that make their products better, make their products survive the testing. Those design changes and those practices then get implemented in their next product. And so while we're learning from the testing, they're learning as well. And so their products just get better and better. And their likelihood of passing the testing and also having a product that is very robust and reliable increases as well.
So today you brought us some, it's normally called show and tell, but on the podcast, we'll call it describe and tell. So tell us about this item here. It's metal, and that's what I can see. So what is it, and how did you test it?
This is actually an insulator that's used in the electrical industry. And so you might see these on high power lines, not something that you would have direct interaction with. But one of the difficult things about these insulators is once they're damaged, they're less effective, and they can actually be a source of heat loss. So one of the things that we want to do is find a way to identify failures remotely. It's a lot safer and a lot easier and less expensive if you do not have to have an electrical worker actually climb the poles to inspect these in person. So being able to remotely identify those failures has been one of the programs involved here at SWRI. And so this is an example of one of the ones that we had tested where we actually induced failures. We created failures so that we could then try to determine the difference in its performance or some way to identify that failure remotely where you did not have to actually physically be in contact with this insulator.
And you have this piece here. Tell us about this.
All right. So this is a small aluminum block, and it's actually representative of a piece of a skid rail. So typically small consumer jets, where you're going to have 4 or 6 passengers, they carry their fuel only in the wings. This particular jet also had fuel in the belly. So in the event that the landing gear fails, not a great scenario, but these skid rails are actually designed into the plane so that if the landing gear does fail, they skid on these rails rather than directly on the plane belly. That's designed so that the fuel does not overheat and then cause a fire. So these skid rails are very important because they're actually sacrificing themselves on the runway to prevent damage to the actual plane and the belly fuel tank. And so we were evaluating different materials to make sure that there was a good balance between the material being scraped away and not too fast so that the material was gone before the plane stopped, and not too slowly that the plane just kept sliding. So this is an example of one of the materials that we were evaluating on that simulated hard landing.
And would that be installed on a commercial plane?
Absolutely. Absolutely.
So many times you're not just testing for, product assurance, but as we mentioned, safety, and really, this could be life-saving.
Absolutely. Absolutely.
So in all your years of testing, do you have a favorite testing story?
Well, one of the products that we test frequently is ruggedized laptops for a commercial manufacturer. One of the tests that we ran was a drop test from 7 feet. And I thought for sure that when we picked up this equipment that there was no way that it was going to actually still work. First of all, I didn't think it would survive the drop. And then I didn't think it would actually function once we dropped it. And we dropped it 26 times, every corner, edge, and face. And by the end of the testing, it was still functional.
Did you drop it onto concrete?
We dropped it actually onto wood that was resting on concrete. But still, from 7 feet, not too many laptops would survive the drop, let alone work once they had been dropped 26 times.
26 times to a hard surface.
Yes.
Yeah, so that's pretty cool.
It is.
So when you realized that it worked, is that kind of a good moment that you had done all your homework and crossed all your T's, dotted all your I's?
It's impressive. When you've done testing on a family of products and the manufacturer has learned design changes and improvements to those products, it's satisfying to know that history of testing has gone into improving that family over the years. And we have a long relationship with this client. We've done a lot of their testing, and it's impressive to see the products that we've tested actually being used in the field by law enforcement and military and even utility workers. It's makes me proud that the testing that we did verified that product for use in those kinds of environments.
How did you get your start in this type of work?
Well, I actually started as a design engineer at another company, a consumer company. And while I was there, I was designing equipment that was for use in the outside world, in the outside plant for the telecom industry. Part of that is designing for surviving those environments. But I found myself preferring the testing, trying to break it, trying to induce those failures, and then using that information to make the design improvements. That kind of got me more focused in the testing aspect, learning how to test, how to increase those extremes, basically how to break stuff and then how to make it better.
So you like breaking things then?
I do. I like learning how to make it better.
Yeah, so you'd call that a job highlight.
I do.
That's pretty cool. So what, aside from breaking things, what do you enjoy most about your work?
I like the variety. SWRI has a breadth of technology that we call deep sea to deep space. And we've tested everything from deep sea to deep space. We've tested subsea connectors used in the drilling industry, and we've tested instruments that are on the space station to make sure that they'll survive the launch into space, and everything in between. I like the variety. You never know what's going to show up from day to day and what kind of challenge you're going to be facing, what kind of problem you need to solve.
And what's great as consumers is if you've tested something being launched into space, then certainly what you've tested on our store shelves is going to work great.
We hope so. That's our goal.
All right. Thanks for the tips today, and thanks for the insight on your industry and what you do. We've really enjoyed having you today, Jenny.
Thank you for having me.
And now, breakthroughs, personal stories of discovery told by the people who lived them. Today, an ancient technique solves a modern-day problem.
Hi, I'm James Oxley. I'm a staff scientist in the Department of Pharmaceuticals and Bioengineering at SWRI. My breakthrough moment is related to the field of microencapsulation, where we're encapsulating or entrapping ingredients into small particles. That's a field we've been active in since 1949. I've been here 15 years, and over the course of those 15 years, challenges and problems are brought to us, and there's a limited tool set or toolbox of materials that we can use in certain encapsulation processes. And we're often asked for a new tool, a new material to solve that challenge. And over these past 10 years, been brainstorming and thinking about how can we add to this or develop something new. And I'd say a few years ago, the breakthrough moment that I would have had is determining what a new material might be. And it actually reaches back 2,000 years to treating wood with what are called drying oils, or if you've done any woodworking, tung oil or linseed oil, you apply it to wood, and over the course of a couple of weeks, that material auto-oxidizes and cures and seals the wood or encapsulates the wood. So I believe I was reading an article in a magazine and just sort of triggered that thought that, well, if this is used for wood and it preserves these ships and boats for thousands of years, maybe it can do the same thing in a microcapsule. And indeed, what I'd hoped would happen did, and that the drying oils can be used to make capsules, can be used to make particles. We can entrap ingredients. And again, this is using chemistry and technology that's been around for 1,000+ years. And so it's really falling onto some new use of old materials. These materials can be used to entrap or encapsulate a variety of ingredients. Capsules that are currently used in things like fragrances, consumer products, foods, maybe even pharmaceuticals, and also getting down into agricultural products, pesticides, animal feed additives. Some of the current products on the market utilize some rather harsh chemicals, also chemicals that may not biodegrade. As we get into the popularization of microplastics and their harm on the environment, there may be pending bans in the future, and so clients are already turning to us for potential biodegradable solutions. And given that tung oil and linseed oil come from plants, they're natural materials, these could be a nice suitable replacement for what are the classic non-biodegradable chemistries currently used for, again, all those applications I just mentioned. All the chemicals we're using are currently used in foods, or they're natural, or they're not harmful at all. So we're trying to stay away and have what I would call it a clean label capsule, if you want. And went through the iterations of finding the right combinations to make particles and capsules. So we just started encapsulating basic things like dyes, lavender oil as an example, limonene, which is a common fragrance. So just some off-the-shelf common things that we've been asked to encapsulate in the past just to prove that we can make the particles, and we have been able to. We're actually onto something where we could solve a challenge that has been plaguing the encapsulation industry for decades and have a potential solution for our clients as they come in and say, do you have something that matches these specifications? And we can finally say yes. And I think that's part of what our internal research project and program is for, is to find new solutions for. So it was quite an exciting moment to see that this could potentially work, and now to see it through fruition is that it actually is working. Making products and materials better for everybody, worldwide, whether it be, again, pharmaceuticals, food. The work we do doesn't just touch one or two people; it touches millions, if not billions, depending on the products that go out there. So.
A disruptive technology that will have a wide impact. Thanks for sharing your breakthrough story, James. And finally today, ask us anything. You ask, our experts answer. Natalia G. submitted a question on podcast.swri.org. She asked, do you guys build robots? And our robotics expert, Matt Robinson, is here to answer Natalia's question and to tell us what's new since we last heard from him. Thanks for being here, Matt.
Thanks for having me, Lisa. I guess the concise answer is yes. We do build robots. It's actually here in our manufacturing robotics and technologies department here at SWRI. We solve the tough to solve automation challenges by building oftentimes custom robotic solutions. And so very, very recently, we actually put through the paces some recent demonstrations of a very large mobile paint removing robot that actually can process commercial aircraft like the 777s you see moving around the airport. So that's been a really exciting, very recent development. And of course, we have other projects and build robots that are much more, let's just say, custom to, say, power line inspection or inspecting tunnels for water movement and different infrastructure type projects like that.
Okay, and robots are involved in a lot of different manufacturing processes, correct? And we're still building robots for those applications as well.
Yeah, correct. Right. So very recently, speaking, kind of moving into kind of maybe some things that are new since we last spoke, we've been deploying a lot of surface finishing, surface processing type robotics solutions, right? So it's been a very exciting time working with clients to solve their challenges, getting people out of hazardous environments. And so all of these can be removing coatings or applying new coatings. And that's, and bringing the intelligence along with the custom robot itself.
So Natalia G., the answer to your question is a definite yes.
Definitely.
All right. Thank you, Matt. And if you want to hear more from Matt about our robotics capabilities, check out episode 2, Robots in the Real World. To submit a question to ask us anything, visit podcast.swri.org and scroll to the bottom, or post your question on social media with hashtag AskSWRI. You can also share your question by commenting on one of our Ask Us Anything posts. Your question may be featured on an upcoming podcast episode. And that wraps up this episode of Technology Today. Subscribe to the Technology Today podcast to hear in-depth conversations with the people changing our world and beyond through science, engineering, research, and technology. Connect with Southwest Research Institute on Facebook, Instagram, Twitter, and LinkedIn. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Benya. Thanks for listening.